In this lecture, we will discuss system design. System design is the third of the 5 phases in the system development lifecycle. Now you will work on the physical design that will meet the specification described in the system's requirements document. Tasks will include user interface design, data design, and system architecture. Deliverable is the system design specification. The goal of the system design is to build a system that is effective, reliable, and maintainable. Effective if it supports the business requirement and meets the user's need. Reliable if it handles input errors, processing errors, and hardware failure or human mistakes. Maintainable if it is flexible, scalable, and easily modified. Will it succeed? Think like a user. Carefully examine any point where users provide input and receive output. The user interface must be easy to learn. Input process should be easy to follow, intuitive, and forgiving of errors. Predefined output should be attractive and easy to understand with appropriate level of detail. Anticipate the future needs. Provide flexibility. The user should have several alternatives so that they can decide what works best for them. Start with a default value that displays automatically. Manage the data effectively. The system should enter and verify data as soon as possible. Each data item should have a specific type, such as alphabetic, numeric, or alphanumeric, and a range of acceptable values. Collect input data as close to its source as possible. Users can design their own output. System designers are more aware of users' needs and desires. A system can maintain data integrity and still allow users to view, sort, filter, and examine data in any way that helps them do their job. Centralized IT departments no longer produce reams of paper reports. Overwhelming trends has been customer-designed output. The user interface itself has evolved. Most users' information needs can be met with screen-generated data which a user can print, view, or save. A user interface describes how the user interacts with the computer system and consists of all the hardware, software, screens, menus, functions, output, and features that affect two-way communication between the user and the computer. Human-computer interaction, or HCI, describes the relationship between the computer and the people who use them to perform their job. Graphical user interface, the main objective is to create a user-friendly design that is easy to learn and use. When you're creating an interface, you should, 1, understand the business. The interface designer must understand the underlying business function and how the system supports the individual, department, or enterprise goals. Maximize graphical effectiveness. Studies show that people learn better visually. Think like a user. See the system through the user's eyes. Use terms and metaphors that are familiar to users. Understand their experience, knowledge, and skill levels. Use models and prototypes. Present initial screen designs to user in the form of a storyboard. Users must test all aspects of the interface design and provide feedback to the designers. Focus on the usability. Open the screen should show the main options. Offer a reasonable number of choices that a user can easily comprehend. Invite feedback. Monitor system usage and solicit user suggestions. Determine if the system features are being used as intended by observing and surveying users. Document everything. Document all screens designed for later use by computer. Number the screens designed and save them in a hierarchy similar to a menu tree. User-approved sketches and storyboard also can be used to document the user interface. Good form layout makes the form easily to complete and provides enough space both vertically and horizontally for users to enter data. Information should flow on a screen from left to right and top to bottom. The order and placement of fields should be logical and totals should be identified clearly. Before designing printed output, ask yourself several questions. Why is this being delivered as a printed output rather than a screen-based information? Which an option for users to view, print, or save as needed? Who wants the information? Why is it needed? How will it be used? What specific information will be included? Will the printed output be designed for a specific device? When and how will the information be delivered, and how often must it be updated? Do security or confidentiality issues exist? How will they be managed? When you look at designing a report, organizations strive to reduce the flow of paper and printed reports, but few firms have been able to eliminate printed output totally. Users find it handy to view screen outputs, then print the information they need for discussion or business meetings. Reports must be easy to read and well organized. Data programs such as Microsoft Access include a variety of report tools, including a report wizard with a menu-driven feature that designers can use to create reports quickly and easily. Microsoft also suggestion tips and videos can help you design a better form or a report. You have several different types of reports. You have a detailed report, exception report, and a summary report. A detailed report provides one or more lines of output for each record process. An exception report displays only those records that meet a specific condition or conditions. Usually useful when the user wants information only on the reports that might require action but does not need to know the detail. Some reports are used for upper management, often want to see totals, figures, and do not need supporting details. When you're creating outputs, you want to have user involvement. Report design principle must be attractive, professional, and easy to read. It should provide totals and subtotals for numeric fields. Analysts must consider design features such as report headers, footers, page headers and footers, column headings and alignment, column spacing, field order, and grouping of detailed lines. Report headers and footers. Every report should have a report header and a footer. Headers identify the report and contains the title, date, and other necessary information. Footer include grand totals for numeric field and other end of report information. Some technical issues that you might have is with output technology. In addition to screen output and printed matter, output can be delivered in many ways. Create the actual form, report, and document and other types of output that might be accessed by workstation, notebooks, tablets, smartphones, and other devices. Internet-based delivery. Web-based delivery allows users to download a universe of files and documents to support their user needs, information needs. It can be delivered. Email is an essential means of internal and external. Blogs is useful for posting news, reviewing current events, and promoting. Instant messaging is useful as a constant flow of communication, especially as team in a collaborative situation. Wireless device is transmitted to a wide array of mobile devices, including tablet computers, smartphones, and wireless. Digital and audio, sounds, images, and video clips can capture stored in digital form. It can be attached to an email and inserted into a clip in a Microsoft Word document. Computer output to design media. Storage can include magnetic tape, CDs, DVDs, and high-density label discs. You also specialize form output. You can have portable, web-connected devices that can run multiple apps, retail point-of-sales terminal that handle credit card transactions, automated teller machines that can process bank transactions, special-purpose printers that can produce labels, employee IDs, cards, driver license, gas pump receipts, and in some states lottery tickets. You have plotters that produce high quality images such as blueprint maps, electronic circuit diagrams. This just shows the different types of input. Traditional was input a keyboard. Evolving is your body motion detection. Emerging is brain-computer interfaces. So basically what this chart shows, it shows you traditional input devices, and these are devices that we're most accustomed to. It shows you things that are currently evolving, and then it looks at emerging technology, where we're going with input devices. When we look at input, we can have batch input, where you have data entry usually performed at a specified time schedule, such as daily, weekly, monthly, or longer. You have online input. A popular online input method is automation, which combines online data entry and automated data capture using input devices such as RFID tags and magnetic data strips. You have source data automation. Automation is fast and accurate and minimize user involvement in transaction processes. You also have your businesses use point-of-sale terminals equipped with barcode scanners and magnetic swipe scanners to input credit card data, automated teller machines that read your data script on the bank cards. Factory employees use magnetic ID cards to clock in and on and off specific jobs. Hospital imprint barcodes on patient identification bracelets and use portable scanners when gathering data on patient treatment and medication. Retail stores use portable barcode scanners to log new shipments, update inventory data, and libraries use handheld scanners to read optical strips on books. Some trade-offs: you had manual data entry is slower, more expensive than batch input because it is performed at a time the transaction occurs and often done when a computer demand is at its highest.